This episode of the HVAC School podcast is made possible by Testo. Now, Testo makes many high-quality instruments for the HVACR industry and many other industries for that matter. I'm actually always kind of surprised when I realize how many different things they make. And I've mentioned a lot the Testo 550 gauge manifold, which I think is one of the best digital manifolds on the market, bang for its buck. Testo 420 flow hood is something I've tried out recently. I did a video on that, which I think is exceptional when you combine the price as well as the capability and accuracy of the hood. The Testo smart probes, we've been talking a lot about checking charge with and without gauges, but the Testo 115 or 115i clamps are a great clamp. And then also the Testo 510i manometer is a great compact manometer that works with the Testo Smart Probes app. And I mentioned the Smart Probes because we've been talking about this a lot with Jim Bergman, his MeasureQuick app, the MeasureQuick app that you can get by going to measurequick.com/download now. The MeasureQuick app is going to work with the Testo tools here very shortly, app-to-app communication, which is going to be tremendous. And then all the I-series Smart Probes are going to eventually sync up with that. Another thing is the Testo 770-3, their meter actually works with the Smart Probes app so that you can do a lot of things that you can only do with a clamp meter, like measure amperage and voltage, and you can actually measure power, which is wattage, right on the 770-3. But in addition to that, I wanted to mention that Testo has the fall promotion. You can find the fall promotion by going to hvacrschool.com/fall promo. And in the fall promo, if you get one of their really high quality combustion analyzers, depending on which series you get, you can also get a free 745 non-contact voltage tester or a free 770-3. If you combine that with the discount that you get at TrueTechTools.com with the offer code GetSchooled, you can get a really great deal. So if you go to TrueTechTools.com, look at their combustion analyzers from Testo, and then go to HVACRschool.com/fall promo, combine that all together, you will get the best deal you could really ever find on a good, high-quality Testo combustion analyzer. Also, big thank you to RectorSeal. RectorSeal is a sponsor of the HVAC School podcast in this episode. And one thing that we've been doing on our trucks here at Kalo Services in Central Florida, my business, we've been trying out the leak freeze product, only in a very specific use case. Older systems with very small form of carry leaks with customers who really don't want to spend the money in order to get it fixed right away. We've been doing some tests with it, and we've been pretty impressed by the fact that this leak freeze product is reducing leak rates or eliminating very small form of carry leaks. So it's a interesting product. It's different than the other products on the market. Some of the other products harden inside the system. Leak freeze does not do that. It builds what's called a flock, which is almost like a very soft scab on the inside of the pipe to block off the leak. It doesn't clog up expansion valves. It doesn't harm compressors. It's an oil-based product. So while it may not fix very large leaks, it's also not going to cause damage to your system by getting stuck in an expansion valve or causing problems with the compressor. RectorSeal has a great offer that you can get some free leak freeze if you go to hvacrschool.com/LF. And if you save your proof of purchase, you can actually get free leak freeze for every 5 that you purchase. So you can find out more about that, all the details, by going to hvacrschool.com/LF. This episode is also sponsored by the Carrier Corporation. As you know, our very first sponsor was Carrier. And I've been doing some reading recently about Willis Carrier and what he actually invented. It's really, really fascinating. And so I'm going to actually create a special link to this PDF of the original manual for the Carrier air washer if you want to read that and kind of see the engineering that went behind it. I mean, Willis Carrier was really a smart guy. Like, he did a lot of work, but mostly what he did work in was humidity. Really, psychometrics is what Willis Carrier brought, and that's where the term air conditioning, when we say air conditioning, before that, there was refrigeration. Refrigeration existed, but people weren't thinking about the entire picture of air. And that's what Willis Carrier really did, was invented systems that could handle all of the ventilation and dehumidification or humidification and cooling or heating of the air. All those things simultaneously, because that's truly what air conditioning is. So if you want to find that historical document, you can go to hvacrschool.com/Willis. That's hvacrschool.com/Willis. This episode is also sponsored by Parker Zoomlock.
Meet Zoomlock, the 10-second flame-free refrigerant fitting from Parker. Reduce labor costs by 60% with no brazing, no flame, and no fire spotter. Discover how Zoomlock can help you be more efficient and productive. Visit Zoomlock.com for more information.
There once was a tech from the south who was always running his mouth. He started a podcast, for his ego was vast, but he can't find another rhyme for South. Brian R.
Like, hats off to those of you who can write a limerick right off the top of your head. I was trying to find a good word other than mouth to rhyme with South for like half an hour, and I couldn't think of anything, but I decided, heck with it, I'm just going to go with a limerick anyway. Today on the podcast, we have Dick Wirz from Refrigeration Training Services, and Dick is one of the few people who I really, really, really went out of my way to get on the podcast, because I'm a huge fan of Dick. I think he does great work. He's a technician at heart, and he really understands technicians. He's one of the premier trainers in the industry, especially when it comes to refrigeration. And he wrote the book on refrigeration for air conditioning technicians, because it's called Commercial Refrigeration for air conditioning technicians. And today, that's what we talk about, commercial refrigeration for air conditioning technicians. So here we go, Dick Wirz. Commercial refrigeration for air conditioning technicians. It's in its third edition, which I didn't realize, because I had the second edition, and I didn't realize how much could change in a book until I went to the third edition. And the third edition really is tremendous. I mean, there's so much added into that edition. It goes into CO2, and I mean, it opened my eyes on a lot of things. I was shocked at how much I learned having already read the second edition going to the third. So the third edition is great. And then also the name of your organization, if I'm not mistaken, is Refrigeration Training Services.
That's correct.
If you wouldn't mind just telling us a little bit about where you came from, how you got into this business, and then how you got into teaching and being an author.
I started out in air conditioning, actually in sheet metal, while I was still in college, and eventually went to work for the company and was in the engineering part of things. Later on, transferred into installation and service and became the service manager. And a sister company was a commercial refrigeration company, and I was fortunate enough to transfer over to that company. And the first couple of days in commercial refrigeration was just awesome for me. And I said, this is where I want to be. And eventually set up my own company along with my partner. And we went into business in 1974. 25 years later, I retired, sold out to my partner who's still running the company. And I got into teaching. Before I retired, I knew I wanted to go into teaching eventually. That was something that was important to me because I had gone to a factory school at Copeland. I think that was about 1991, and had some awesome instructors. And I realized, even though I'd been in the trade for 15 to 20 years, I realized how little I knew. And I came back to my company and started giving half-hour classes once a week, because I realized that my technicians needed some help, as I had done. And while teaching my technicians, I realized that's what I wanted to do when I retired. And I went to a community college and started teaching at night part-time and really enjoyed it. But once again, I had an eye-opening experience about there was a lot more that I needed to know before I could answer questions from my students. When I first started, I thought I knew everything. And after the first semester, I realized there was a lot more I needed to know. So I spent the next couple of years going to factory school seminars, both on air conditioning, refrigeration, and then came back to the classroom much better prepared. Then from there, I developed some PowerPoints. At first, they were just to keep me on track. But I had my wife, who is a graphics person on a computer, come up with pictures and drawings and so forth to illustrate what I was trying to teach. And we would get refrigerant flowing through a pipe or electricity going through a wire or something like that. And when I started using in the classroom, students were saying, why don't the other instructors have this? One thing led to another, and we started making instructor CDs. Everything that I put in the instructor CDs that I eventually started selling were things that I used in the classroom. And so we would use them, edit, and get them the way we wanted before we would allow them to be sold. And so that's what we've been doing since about 2005, is primarily selling the instructor CDs to instructors across the country. And we have them in all 50 states and internationally as well. And then I got involved in a book. That was kind of crazy, but a publisher convinced me that I had done a course in commercial refrigeration. All I had to do was take that course and put it into the proper format, and I could come up with a textbook. Well, I thought that would be a good idea because I was trying to help air conditioning technicians have a resource that they could use to at least get them off of the ground as far as what the similarities and differences in commercial refrigeration and air conditioning are, so that they could expand their scope. They started out in paperback, black and white, and it took off. So next thing was hardback, color, and we did the third edition, which came out in January, but I've got a file full of things ready to do on the fourth edition. So that just keeps expanding because of things that not only I have found, but questions that others have sent me as far as needing to understand better certain things in commercial refrigeration. So that's basically it.
Yeah, that's a really, and you know what's interesting is that such a consistent story with the best trainers out there. The best trainers out there always had a measure of field experience. You have more than most, I think. But in talking to, guys like Jim Bergman or Dan Holohan as a guy who I've had on the podcast, or Jack Rise, these guys, they've been in the field, and so they've had that sort of hands-on experience, and then they're able to translate it in a relatable way to the people who are actually doing the work. And that to me seems to be different than people who come maybe more from the engineering side, who have very valuable information, and it's very important and very useful, but it's hard for them to translate that to the technician's mind because they haven't been in the trenches experiencing it in that same way.
I agree with you, yes.
So I want to highlight a couple things about this book. There's two things that make it different. The one is that you have been fairly unashamed about giving what you call TROT, which is rules of thumb, basically, for technicians when you don't have data to reference from a manufacturer, which is a bold move, and I want to talk about that in a second here. But also, you have some excellent graphics. I mean, it's not just good photography, but also really good graphics that show, everything from the flow of refrigerant and the different temperatures and pressures at different points, even in your diagnostic examples, but then also even some of your electrical diagrams, like your defrost diagrams, are excellent. They're unrivaled in the trade from the standpoint of a technician's mind. They're not necessarily traditional schematic diagrams like you would see in a traditional textbook, but they communicate what a technician needs to know who's actually out in the field working on the actual product. So I just kind of, you went over this briefly, but what mindset did you take into writing the book?
When I started writing this book, it was from my classroom perspective, looking into the eyes of my students who are often technicians and trying to understand where they were coming from and trying to relate what they already knew to what I was trying to teach them. I'm not the smartest guy in the world, and I did have difficulty understanding air conditioning and refrigeration just like everybody else. But I think I was able to remember what was confusing to me. And I think I utilized that memory of what were the tough concepts for me to helping me to learn it well enough to explain it simply, as if I were talking to a new technician beside me on the job, trying to explain to him what this concept was about. I didn't realize how important the basics were until I went to that Copeland school. There were two people that were teaching that. It was George Story and Glenn Hannigan. And I'll never forget those guys. There was a class of about 30 of us at the factory in Ohio. And I thought I was going to learn about compressors. But out of the 5-day course, the first day and a half was nothing but basics, superheat, subcooling, things like that. I raised my hand the morning of the second day and I said, I was kind of bored yesterday when you were going over the basics, but then I realized I didn't understand the basics. And I really appreciate you taking a step back and doing it that way to help me understand it better. And Glenn Hannigan smiled. He said, that's why Copeland asked us to start giving these courses because people were complaining that Copeland was making a bad product when in fact it was the technicians did not understand the basics, did not understand what the compressor was supposed to be doing. And that really helped me. And I looked at how they presented things, and that's how I presented them to my technicians at my company and started the training program.
Yeah, I think there's, with training, and so for anybody who's been into different manufacturer training courses or you've been to trade school or whatever, there's a couple different categories that I put things in. One is the engineering side. And if you've ever read a lot of the ASHRAE documentation, you know what I'm talking about, stuff that ASHRAE publishes. It's very important stuff, but it's highly engineering driven, and there's all sorts of numbers on a page. I mean, formulas, numbers, charts, all that sort of thing. And I'm not discounting that, especially when you're on the design and engineering side. But for a technician sees that and they get overwhelmed pretty quickly. And so in a classroom environment, that's generally not super effective. And then there's the other side, which is the very simplistic. I mean, most of the manufacturer training that you go to nowadays is, teaching you how to hook up ABCD to their particular interface and the different things to consider with their particular product. And the problem with that is it's good information. It's also very good to know, especially if you work on a particular product. But it isn't general enough that it gives you a real understanding of how things work. It's so much more of the what and the how and not really the why. But the sweet spot, I think, that the industry needs, especially right now at this juncture that we're in with the skills gap and everything that we're facing, is training that really teaches us the whys, and not the whys at the math and engineering level, but the whys at the technician level, the whys at the installer level. This is why when a compressor fails, here's the reasons why a compressor can fail, and here's what it looks like when you break this compressor down. For the people who are the mechanical minds, the visual learners out there, and your book does a really, really nice job with that. I wanted to address this question of rules of thumb, though, because this is one of the things that I really appreciate about your book, because most books aren't bold enough to do this. Did you get any pushback in putting these, as they're listed here, the TROTs, the rules of thumb? Did you get any pushback from the industry on that?
Yes, I did. And the attitude was, well, you can't actually say that 10 degrees of superheat is the normal superheat, because it varies based on equipment, application, so forth. And I agree with that. But the trouble is the industry for years seems to, like, let's say you're reading something and it says, well, you should have the appropriate superheat for this application, period. And that leaves the technician in the dark. Well, where do I find this information? So in training my technicians, I had to come up with rules of thumb, and I actually used them on the job. And I said, well, is this accurate enough to get them in what I call the ballpark? In other words, get them close to what it should be. And if nothing else, if they understand what the approximates are, when they are talking to a knowledgeable factory rep or an engineer, they are able to either ask questions or to understand what the rep or the engineer is telling them. If they have no idea of the approximations, then they're completely lost, and they'll be confused because one engineer will say one thing, another one will say another. For instance, we talk about superheat, but is superheat taken at the evaporator or is it taken at the condenser? And the answer is it's taken at both places, but it's tremendously different because Copeland, if you ask them what proper superheat is, they'll say 20 degree superheat. And if you ask Heatcraft what the proper superheat is, they will say 10 degrees superheat. But the difference is that Heatcraft is taking it at the evaporator outlet, and Copeland is saying, we want you to check it at the compressor inlet, because by the time it gets up to 20 degrees of superheat, we know we're not going to have a problem with flooding. And it's only through these rules of thumb that we are at least able to ask the right questions of the people that we're trying to network with.
Yeah, and that's what you have written is exactly what the industry needed. I remember I created my first training program for technicians. I think it was probably in 2002 or 2003, in that range. And I was looking at great resources like the Racked Manual, Modern Refrigeration, these types of manuals, and they were excellent. But and even in those books, there are some rules of thumb, and there are some of those things, general design conditions and those sorts of things. But I still struggled because I was attempting to communicate ideas like design temperature difference on an evaporator coil or a condensing temperature over ambient on a condenser. And they were buried in these tomes of very important works that cover the entire, depth and breadth of the industry. And so I attempted to make a lot of this stuff on my own, and a lot of it was wrong, because I didn't know what I was doing. But over the years, I've learned that a lot of the best trainers, you would fall in this category, and I think Jim does a lot of the same sort of thing, is that you use what you see, what's being experienced out in the field, and then what you test, what you can prove through testing. And you put that in a way that's beneficial because truthfully, in this business, and we're going to talk about this in just a minute, we're dealing with temperatures. I mean, that's largely what we're doing. Even when we're looking at pressures, we're converting those to temperatures. And if we can get within a couple degrees of what it's going to be, even, there will be some variation manufacturer to manufacturer, but if we can get ourselves within a couple degrees, we're going to be in a much better position than if we didn't have that information at all.
Exactly. Close may not be good enough, but it's a whole lot better than not being close at all.
Correct. Yeah, and that's an important distinction. And it's also important that technicians don't just stop with rules of thumb, and you would say that, Jim would say that, and I would say the same thing. You don't just stop with a rule of thumb. You get into the manufacturer data, especially if you have access to it. But a lot of times the rules of thumb are going to get you in the ballpark, like you mentioned before, enough that, as a perfect example of this, when you talk about hot pull down on a piece of refrigeration equipment, you really need to get to a certain level before you can even accurately start to dial in a superheat, say. And if you don't have any idea what you should be at, even in a hot pull down, then you have a new technician who has literally no clue what they're supposed to have. They're not going to even be able to get to close box temperature. So actually, let's do that though. Let's talk a little bit about the idea of conversion of temperatures to pressures and how an AC technician, because most of the audience is going to be air conditioning technicians who are out there fixing air conditioners day in and day out. And they're overwhelmed by the idea of working on refrigeration equipment because the box temperatures are different and the refrigerants are different and all of those sorts of things. So what are some of the first things that you tell a technician as it relates to maybe their overwhelm that they're feeling about working on refrigeration?
Well, let's start out with the temperature. I like to call it the evaporator TD because it's the temperature difference between the inlet air temperature and the temperature or the saturation temperature of the refrigerant that's inside the evaporator. And that is something that you can depend on as far as being very indicative of what's going on. The problem with just standard TD usage where the inlet air and the outlet air are being used is a lot depends on airflow. And this is especially important in air conditioning. And of course, it does translate to refrigeration as well. But let's take air conditioning, which most people understand. When I came into the industry, there was one refrigerant that was being used. That was R22. And the experienced techs who were teaching me did not understand refrigeration temperature. They only understood pressure. And when I would ask them, well, what does the suction pressure supposed to be, or what should the suction pressure should be, they say, well, about here, based on it's a hot house and we got a lot of humidity here, so it's going to be up around this area. And I said, well, what about the head pressure? Well, it's a hot day out here. We got a load on the house, so it's going to be up about in this area. And he's pointing at this set of gauges. And I'm going, shaking my head like I know what the heck he's talking about. But it was all kind of guess. What I didn't realize until later on is, number one, they had no idea about refrigeration temperature and saturation temperature. And this, of course, was back in the 1960s when a lot of this was very new and there wasn't a lot of training going on. And these guys in the field were basically thrown in there and they were trying to figure it out for themselves. So I don't blame them, but I realized that they were able to finally get around to the point where they could say if it was working right or not. And of course, those old systems being 7 and 8 SEER, you just add gas to them and they seem like they would run. They're not like things are today. But when I did get into refrigeration, I no longer could depend on a pressure being in a certain area because At the time, there was R22 being used in commercial refrigeration, there was R12, and there was R502. And we had a wide spectrum of ambient temperatures as far as the box was concerned. Everything from 55 degrees down to minus 40 degrees. And so I had to learn about evaporator temperature, condensing temperature, and how it relates to the air that's going through it. And this is the difficult and the scary thing for air conditioning technicians who are trying to get into commercial refrigeration. It's like, what the heck is it supposed to be? So once again, let's go back to air conditioning. Now we know that in air conditioning, most of the time, the evaporator TD, the difference between the air coming in and the refrigeration temperature, is approximately 35 degrees. So if I have 75-degree return air, I should have a 40-degree evaporator temperature. What happened?
Let me add real quick there, because this is one area that technicians I've heard get confused, and you're explaining it very well. But when we're saying TD, a lot of technicians will say TD, temperature difference, and they're thinking delta T. So from here on out, when we say delta T, we're talking about the air temperature difference across the evaporator coil.
Exactly right.
Meaning, rule of thumb a lot of guys throw around is 20 degrees, even though that's not always the case either, but that's the rule of thumb a lot of guys say. We're talking about TD as in the difference between the boiling temperature of the refrigerant inside the evaporator coil. Our suction saturation is what we're looking at. The comparison between that suction saturation temperature and the temperature of the air in the box.
That is correct.
So in the case of refrigeration, or in the air in the return in the case of air conditioning. So I just wanted to make sure that everybody's on the same page with what Dick is talking about here.
Yeah, and I'm not saying that using delta T is bad. I'm just saying that there are a lot of misinformation and easily made mistakes by going with delta T. And it boils down to, in air conditioning, delta T can be fairly accurate because you've got a mixture of the air coming off the plenum into the first length of duct. So that is pretty good. Whereas in commercial refrigeration, we're dealing with unit coolers, or what I call coil type evaporators that have a propeller fan on them. And to try and get an accurate measurement coming off of a propeller fan is almost impossible. So we couldn't use a delta T very easily, even if we wanted to. So the evaporator TD is so much more indicative of what's going on. And that's what we use. Now, on the other side, which air conditioning people usually recognize, is your condenser split. And condenser split has to do with the ambient air, the air surrounding that condenser that's coming into the condenser, and once again, the saturation temperature or the condensing temperature of the refrigerant inside that condenser. And on 10 SEER equipment, for years, it has been approximately 30 degrees. So what should it be? Well, if it's 100 degrees outside, then I should have a condensing temperature that's approximately 30 degrees different than that.
Yeah, so 130 degrees is what you would expect your condensing temperature, which is, you take that on your liquid line, and that's, if you have the gauge built in, or you have a testo or something that shows you, that's going to be your condensing temperature, your condensing saturation temperature, your liquid saturation temperature, whatever you want to call it. It's what you're seeing on your high side gauge, not looking at the pressure, but rather looking at the temperature that relates to that particular refrigerant at that pressure.
That is correct. And so we take that a step further. Now we know what the temperature of the refrigerant inside that condenser is supposed to be. Let's just now take a temperature of the liquid line that's leaving the condenser. And let's say that the liquid line leaving the condenser is 120. Well, it's 10 degrees cooler than what's going on in the condenser itself, and that's what we call our subcooling. And for years, air conditioning was diagnosed with one or the other, either the head pressure or the suction pressure. And to many in the old days, it was like, gee, you have to take both into consideration. Then we moved on to understanding what subcooling was about, how it was such a great indicator of the amount of refrigerant, usable refrigerant in the system. And about superheat. Superheat was slow in coming because we didn't have digital thermometers that could actually read the proper temperature of the suction line. If we used pocket thermometers, it was a guess. So that wasn't even taken into consideration.
Even when I started in the business in 2000, we were still using pocket thermometers. I mean, it's crazy. We were measuring superheat with pocket thermometers, either jammed underneath the Armaflex, or, some guys would electrical tape it with a piece of Armaflex over it. That was the typical thing. And in my company, I was the first one to buy one of the Fluke clamps with the K-type thermocouple. And when I got that, everybody, thought it was the greatest thing since sliced bread. It's amazing how much that's changed even in the last 20 years.
I know it has. And those guys who are coming into the trade right now are like, well, why didn't you use this before? And the old guys that have been in it for 20 years said, well, we didn't have it. And hopefully they've gotten on the bandwagon. But anyway, so in air conditioning, we had that 35-degree evaporator TD in the cooling side and the low side of the system, and we had a 30-degree condenser split in the high side of the system. And that was pretty much what we dealt with, because those would go up and down with the air temperature that was coming in. If I had a 75-degree return air coming into my evaporator, I should have a 40-degree evaporator temperature. If, however, the air temperature coming into the evaporator was 80 degrees, then my evaporator TD would still be the same, 35, but now my evaporator is running at 45. And once my students understood that concept of what it was supposed to be doing, they were better able to diagnose what the problem was when it wasn't doing that. And it's amazing how that evaporator TD will hold for about 5 or 10 degrees on either side of the normal area based on the loading, just as condenser will do the same thing with that 30 degrees. If it's 100 degrees outside, it's going to be 30 degrees higher than the outdoor temperature at 130. If, however, I have 70-degree ambient air, I'm going to have, again, 30 degrees above that will be my condensing temperature, or 100 degrees. That works very well between 70 and 100 degrees. Once you go over 100 degrees or you go under 70, some other things take place and it gets a little bit screwy. But still, you've got a rule of thumb of 30-degree condenser split to work with. You have a rule of thumb of a 35-degree evaporator TD to work with. You have a rule of thumb of 10 degrees of subcooling, and you have a rule of thumb of 10 degrees of superheat. You are now ready to do a pretty good job with air conditioning.
Yeah, and that's and the same thing in refrigeration that there is in air conditioning. And this is what I talk about all the time on the podcast, that you're always better off to have a concert of readings that agree that the system is functioning properly, or they can alert you if something is functioning improperly, than to just rely on single reading sets. So many in air conditioning, so many technicians, and the guys are probably getting sick of hearing me say this sort of thing on the podcast, but so many technicians will hear, well, you set the charge by superheat on a fixed orifice, and you set the charge by subcool on a TXV. And while that may be true by manufacturer specs, checking everything, checking your superheat, your subcool, your suction pressure, your head pressure, or your better way of saying it would be your condensing temperature and your evaporator temperatures, and then also taking your delta T, taking the concert of all those things on an air conditioning system, give you a really good look into the functionality of the system. And the nice thing with refrigeration is you check many of those same things, with the exception being delta T, on a refrigeration system. And as long as you know what's different in the case of a refrigeration system, how those kind of fixed numbers that we look at, how they change, then you're going to be in a really good position to tell the same thing about a refrigeration system.
Exactly.
So let's talk about some of those. Let's go through some of the common evaporator TDs that we see. And so again, when we're talking about evaporator TDs, we're not talking delta T. We're talking the difference between, in the case of refrigeration, the box temperature, the temperature in the box, and the temperature of the refrigerant boiling inside that evaporator coil. So the saturation temperature that we're seeing on our suction gauge. So what are some of the common rules of thumb that you can count on pretty well?
On a walk-in refrigerator, when you're sizing up the system, you're looking at an evaporator that will produce a certain BTU requirement. And if you look in the manufacturer spec on their coils, it'll say either 25-degree evaporator for medium temperature, or it'll say a 10-degree TD. And they're designing that coil at a 10-degree TD, but they've got other BTU capacities at other temperatures, at a 5-degree TD, at a 15-degree TD, at a 20-degree. But on my rule of thumb, most walk-ins from a manufacturer's standpoint are set up at a 10-degree TD, are designed for a 35-degree box temperature, and therefore at 10-degree TD on a 35-degree box, the evaporator temperature should be running at about 25 degrees. That is my saturation suction temperature. And that's a TD we work with on medium temperature. Now, on low temperature, it's exactly the same. It's at 10 degrees. However, we're working at a box temperature of minus 10, and we're still dealing with that 10-degree TD. So 10 degrees lower than minus 10 is minus 20. And that is the design conditions for the evaporator, is running at minus 20 degree suction temperature. No matter what refrigerant you have, if you're using R12, R34, 502, 452, 404, I don't care what refrigerant you're using, those temperatures will be the same. It's just the pressures that are different.
Yeah, absolutely. And that's what is so relieving as a technician. Once you understand this, because with the condensing temperatures, you don't have quite the variation. Say you don't have quite the variation in what the outdoor temperature is, obviously. Whereas in the case of the actual evaporator, the box temperature varies quite a bit depending on the job that it's doing. And so if you understand this is the primary point of variability as it relates to the refrigeration circuit, at least, is the design temperature of the box and the TD that's designed for that evaporator coil in that box. Is that said correctly?
Yes. And I was thinking why the change from R22 to 410A was so disconcerting for many air conditioning technicians. Well, that was because originally, our TDs were going to be the same. If we used R22 and R410A in a system that was designed with a 35-degree TD evaporator and a 30-degree condenser split condensing unit, the temperatures would be the same, although the pressures were different. What happened, however, is when we went to 410A, we increased our efficiencies. And we went from 10 SEER up to 12, 14, 16, and on up from there. What happened with our condenser splits? Our condenser splits dropped down. They went down from 30-degree condenser split down to 20-degree condenser split. And a lot of the air conditioning technicians were confused by this. They understood that 410A was at a higher pressure, but the temperatures didn't relate to them, and so they got very confused. And that's why, if you understand refrigeration concepts, you're going to be able to understand your air conditioning concepts much better, because it's only going to get more technical as we learn how to make things more efficient. And it's going to be a fun ride, I'll tell you that. And you've got to understand those basics, the TDs and the temperature splits and so forth, to even keep up. But at our school, I taught at Northern Virginia Community College, and when I first went there, they were teaching commercial refrigeration first. In the first 2 semesters of it was commercial refrigeration. I'm going, wow, that's kind of strange. Most of these guys are going into air conditioning. However, I realized after teaching that a couple semesters, that was fantastic, because by the 3rd semester, they went into air conditioning. They were much better prepared than if they had started out with learning about R22 and just one type of system.
So very simply, if you're going to focus on one thing, if you're converting from air conditioning to refrigeration, and there's one thing you really want to learn first and just wrap your head around, it is this idea of evaporator TD, evaporator temperature difference between in the case of air conditioning, the return air temperature and the boiling temperature, saturation temperature inside that evaporator coil. And then the same is true for refrigeration. But in addition to that, there are some other things that you want to at least understand about a refrigeration system when you walk up to it. And one thing that a lot of technicians will notice if they go into a commercial refrigeration rack house, for instance, or if they were working on a small reach-in, they'll notice that in a lot of cases, they'll have frost on the suction line going into the compressor. And of course, that scares the bejeebers out of a lot of technicians. So can you speak to that quickly?
Certainly. Frost only indicates the fact that the temperature of that pipe is below freezing. That's what Glenn Hannigan said in one of the first series of classes I was in, and I didn't really understand what he was saying until I saw a picture of a compressor at the Copeland factory that was completely encased in ice. It apparently didn't have any defrost going on, and they took a picture of it and they said, "Does this indicate flood back?" And everybody in the class goes, yeah, of course, and they said, "No, check your suction line temperature and then compare that to the saturated suction temperature that you're going to see on your gauges." And we were looking at that, and the saturated suction temperature was -10. The temperature of the line was at 0 degrees, and the difference was 10. And it was like, hold it. There's 10 degrees of superheat. There's no way it could be flooding. Well, it was because that line temperature was 0 degrees, and over time, it just built up a heck of a lot of frost. So for me and the people in the class, that was really an eye-opener. However, a lot of air conditioning technicians see that, and they have a heart attack because you don't see air conditioning lines frosting. And why is that? Well, go back to that 35-degree evaporator TD. If I've got 75-degree air temperature coming into the evaporator, my evaporator is running at 40-degree temperature. I pick up 10 degrees of superheat. My suction line coming out of that evaporator is 50 degrees, 10 degrees higher than the 40-degree evaporator. 50 degrees is never going to form any frost. But let's say for some reason or other I have flood back and I'm not boiling all that refrigerant off in the evaporator. Or let's say that somebody has not changed the filter. What happens to the evaporator temperature when you restrict the air? Actually, that TD of 35 degrees holds. In other words, it thinks that maybe it's, let's say, 50 degrees because it's full of ice on that coil. The air that's touching it is 50 degrees, and you take 35 degrees below that, you've got 15 degrees. Doggone, that suction line is going to be really cold, and it's going to start frosting. So frost is just an indication that that line is below freezing. Is it normal or is it not? That's what you have to determine.
And that's something that I think technicians, if they think about, they'll look at a cooler, for example, and they'll say, well, yeah, but the cooler's supposed to only maintain 35 degrees, so that's above freezing, right? Well, true, but the evaporator coil has to be lower temperature than the space temperature in order to transfer heat out of that box. And so if you have as an example, let's say you have a walk-in and you've got a 35-degree box, but now you have a 10-degree TD, that means it's 25 degrees. That suction line, if it's exposed, if it's uninsulated, is still going to tend to freeze over time. And so you have to have some form of defrost in pretty much every type of refrigeration that exists. There has to be some way to deal with ice because you're dealing with evaporator temperatures that are below 32 degrees. As soon as you're below 32 degrees for a sufficient amount of time, you're going to have ice as long as there's some moisture in the air. And so talk about the different types briefly of defrost that go into refrigeration and kind of how you can tell which one is appropriate for different circumstances.
Well, in a walk-ins, they have that 10-degree TD. On a 35-degree box, you've got about 25-degree evaporator. You are going to be building up a little bit of frost in there. But under normal circumstances, the thermostat will be satisfied because the compressor is going to bring that box temperature down, cycle off on the thermostat, but the fans continue to run. And this is something to remember. In commercial refrigeration, we keep those fans running all the time because they are helping us to defrost our evaporator during the off cycle. Off cycle meaning when the compressor is off. So let's say that the unit runs for 10 minutes and it cycles off on thermostat and it's off for 5 minutes. During that 5 minutes, the evaporator coil that was at 25 now relatively quickly gets up to 35, the box temperature. That is above freezing, and it will defrost the frost that's on those evaporator coils. Usually, they start forming where the pipe touches the fins, and we really don't see evidence of that out at the end of the fins. So we don't really recognize it as such. But let's say that they're using the box all the time. In other words, the door's open all the time, or they're putting hot product in there or something, and the unit does not have time to cycle off. And it runs for 2 or 3 hours straight, and there's no time for it to shut off. Well, that frost buildup between the pipe and the fins will start migrating out to the edge of the fins, and it'll eventually block the airflow. Now it stops cooling because it's not getting the air across the evaporator properly, and it continues to run until it freezes itself up. In those cases where we have that happening, there's a couple things we can do, and one of the simplest is to add a defrost clock that manually shuts that unit off, usually at night, for about an hour, sometimes as much as 2 hours. And that's when nobody is around. That's when the doors are closed and the product temperatures have come down. The box temperature will go up a few degrees, but not that much. It will give the coil time to defrost itself at night. And that's one of the ways that we do it. In reach-in refrigerators, the evaporator TD is 20 degrees. So let's say that we have a reach-in refrigerator that is designed to maintain 40 degrees. The evaporator is running at 20 degrees below the box temperature. Because the coil temperature is colder than we had in that medium temperature walk-in, we have a tendency to freeze up a little bit faster in there. A lot of manufacturers actually put the thermostat bulb into the coil fins because they are sensing that temperature in the fins, so that if it does freeze up, because they keep opening the door and closing the door and putting in warm product, which they have a tendency to do, if it does freeze up and it does cycle off on the thermostat is not going to come back on until that frost has defrosted completely. So that's the way that usually the reach-in boxes are done. Again, if that doesn't do it, we'll add a clock to that one too and have it do another defrost at night.
And then finally, when you have freezer applications, then you actually have to add heat because the box temperature itself is lower than 32. And when that occurs, you actually have to have a defrost that adds heat to the coil to get that ice off.
Yeah, it's a little bit more intricate because we have several things going on there. Like I said, we had the fans running continuously in your medium temperature boxes. However, of course, when it goes into defrost on a freezer, we have to shut the fans off while those heaters come on. And usually they're electric heaters that are embedded in the coil. And then we have to have something that tells it to go back into defrost when all that frost is melted. Then we can't bring on the fans right away after defrost because we'll blow some of the residual moisture off of the fins into the box, which will turn into icicles, and also it'll blow some of that heat. So we have to delay the fans, and we delay the fans until the temperature of the coil gets down to a predetermined amount. So there's a little bit more to freezers, but once it's explained, it's very logical, and all of them are done the same way. As far as wiring, as far as how time clocks work, and about the different controls for both the fan and the defrost termination. So it's not as scary as you might first think.
And that's actually one thing about refrigeration that I've noticed is that in some ways, when you're coming from air conditioning, may seem overwhelming, but in many ways, the controls related to refrigeration are more consistent than the controls that you see even in, say, residential air conditioning, where you could deal with, 10 different manufacturers' proprietary communicating controls, especially nowadays, and all sorts of different thermostat manufacturers. Obviously, you'll run into cases where refrigeration equipment is tied into, energy management equipment or building automation or something like that. But in general, most of the controls that you work on in refrigeration tend to be more consistent. Would you agree with that?
Definitely. As a matter of fact, air conditioning has gotten into some very fancy controls, and especially proprietary controls, which makes it very difficult for a technician who's working on 3, 4, 5 different brands of equipment to figure out what's going on. Whereas in refrigeration, we've kept up with the old school stuff, and we're just now coming into the demand defrost, which has been used in heat pumps for a long time. Now we're just getting into it in commercial refrigeration, which is strange. I should say now, it's been out there for 15 years, but it's relatively new. And like anything else, when you first see it, it's scary. What you have to do is to go to seminars that are given by the manufacturers and learn about it. Any company that does not do that is really losing out. Yes, it takes their guys off the road for maybe 4 hours, but they're going to spend 40 hours worth of wasted time if their technicians do not understand the latest things that they're working on. So once you get a feeling for that, even though a lot of it is proprietary, it will transfer over to other manufacturers, and it'll make it easier for you to pick up those. You'll say, well, so-and-so does it this way. How do you do it? And you can relate. And that's one of the biggest things that I found is beneficial to technicians, whether it's in a book or it's in a classroom or it's on the job, is relate to what they already know or understand, rather than try and bring in a whole new concept. But I digress. I'm sorry.
No, that's exactly. And in fact, that comes down to the root of what learning is anyway. When a baby learns something, that's what the human mind is doing, is it's relating something that they already know to something else in order to make sense of it contextually. That's how we learn how to read. That's how we learn how to drive. That's how we learn everything. All those things that we now kind of consider as just the sixth sense, we just know it. We learn through context, taking what we already know and injecting some new things into it and relating those two things together. And that's what all good teachers do. And I think you've recognized that and you've put that into writing very well. So let's give an unideal circumstance here, but a circumstance that I think a lot of technicians find themselves in. So you're an air conditioning technician and you end up getting thrown into a situation where you're expected to work on some simple refrigeration. Let's say it's a convenience store application and you're supposed to work on a walk-in or a reach-in cooler in one of these applications. What sort of mindset tips would you give a technician who's walking into this and feels a little nervous or overwhelmed by that prospect?
I think we have a tendency to diagnose what we don't understand as being a problem because we don't understand it. By that, I mean, let's say that we replace the part first that we understand the least. So if you don't understand how a refrigeration system is supposed to operate, you're going to blame the compressor first off or the expansion valve first off. And you're not going to look for the simplest things. Like I tell my students, when you actually go on a job, most of the time it's boringly simple. Dirty evaporator, dirty condenser. What happens in air conditioning? You usually run into a problem that was a result of a clogged up filter. And you don't get as many of those difficult problems as you might think. So look for the simplest thing first. Are the fans running? Are the coils clean? Does it have refrigerant in it? Is it off on high pressure? Is it off on low pressure? Simple stuff.
Yeah, I mean, that does seem to be true in most of the industry, is that guys will diagnose I think the most common one that we see is the board. It's got a bad board in it, and they don't understand what the board's even supposed to do or the inputs and outputs. I think what I would add to that is that if you don't understand how something works, then you have no business condemning it. So if you think it's this thing, but you don't understand how it works, then take the time to understand how it works, or get someone on the phone who does understand how it works, or something, bring them alongside you, whatever, before you go ahead and condemn this part or say that this is the problem or start to rip things apart that ought not be ripped apart. And I think, like I keep quoting Jim Bergman here, but he says the same thing. So often it's cleaning. And when guys start connecting gauges even to pieces of equipment that they don't understand at all, or they don't know what the way he puts it is, if you don't know what the pressures and temperatures should be, then you have no business connecting to it because you're not going to know if they're correct, even if you do see something on the gauge. And I think that's a really good point. So for technicians out there who have no perspective on these things, I think a great place to start is probably your book, honestly.
Well, it is. And I think another thing is that we need to build up a network of people that we can call. I remember as a service manager, the guys were calling me at the office when they had questions. However, when we got into everybody having a cell phone, they were calling the guy who was on the call before or one of the lead technicians and talking to them, and it freed up me a lot. But what we did is every Tuesday when we had a service meeting, we encouraged people to bring up things that they stumbled on during that week, so we all learned together. And once you start learning all together, whether it's in your company or whether it's as an industry, then everybody benefits. So building up a network of people that you can contact quickly is extremely important. And one thing that I told my technicians, I gave them phone numbers of the service reps for all the equipment that we were working on. But I was emphatic about they were only to call them if they were completely flummoxed with what was going on, and they had to have all the information. Ambient temperature, superheat, subcooling, pressures, temperatures, model numbers, serial numbers, everything had to be right there. And by getting all that information, 9 times out of 10, they solved their own problem. They didn't even have to make the call. But when they did make the call, it was a matter of when that service tech saw that one of my employees was on the phone, they knew that they had the information. They knew they'd already checked all the easy stuff. It was going to be an easy call for them.
Yeah, that's so important because it's not only important, like you said, because a lot of times you find the answer before you even call somebody, but it's important to have a reputation in the industry as somebody who does the due diligence and isn't looking for hand holding. This is not an industry that works well with people who want their hands held all the way. And as you know, we're facing a struggle with this with a new generation who's kind of used to having their hands held. But truthfully, you've got to get beyond that. You've got to get to the place that you're doing all of this kind of legwork beforehand. You're checking your evaporator coil condition and whether your fans are running and your condenser coil condition and your pressures and temperatures as needed, depending on the type of equipment that it is, before you start calling somebody. Because it isn't a bother. I mean, you can attest to this, I'm sure. It isn't a bother if somebody contacts me and they have all their information and they're asking me a straightforward question with all the data. It is a bother and it is an inconvenience when I have to hold their hands through the entire process.
Yeah, I had a guy to call me one time. He said, one of your students gave me your phone number, and so he said, you know the answers, and he told me with the head pressure and the suction pressure and asked me why the evaporator was freezing up. And I says, what's your superheat? What's your subcooling? What's your ambient temperatures? And as far as superheat and subcooling, he says, well, I don't have the electronic meters to check that. And I said, well, what are you doing working on equipment? Some people have no business being out in the field. They have no training, and it's just really sad. And they're the ones who give those of us who are trying to do right by our customers, they're the ones who give us a bad name because they think all technicians are dumb like that and they're just BSing them. But I tell you what, this is not an easy industry. And I've had students come in and they didn't think they needed math skills and physics and things like that. And I tried to hide that fact in my teachings so they wouldn't be scared. But doggone, there's a lot to this industry. Both electricity and refrigeration systems are tough, and there's a lot to learn, and you have to be smart, and you better learn it.
Yeah, especially if you want to succeed, especially if you know, have aspirations of getting into management or maybe owning your own business one day. You've got to excel in all these areas, which is another thing I wanted to mention about the book is that you cover business skills in it as well, which is incredible. You know, you don't usually see a book like that primarily focuses on technical things, actually talking about business skills. But there's a lot of good tips in there that I picked up for our business as well of how to run a successful refrigeration business. Not just the money side, but also customer service and a lot of other things. And I think it's a very good, I know I keep talking up the book, so don't get the wrong idea here. I really do. I'm not just talking Dick up because I have him on the phone here. I really have appreciated the book, and it's done a lot for me. So I wanted to kind of give you a quick opportunity. Is there anywhere that people can find out more about you? Obviously, the book's one place. Maybe some things you're doing in the future with refrigeration training services.
Well, we have a website. It's www.hvacteaching.com, hvacteaching.com. And basically that was set up just to market our CDs. And nowadays CDs aren't used too much, but that's pretty much our logo. These CDs are for instructors, how to teach students better through visual representation and through animations of PowerPoints and so forth. But we're going to be adding to that. Anybody who wants to contact me directly can contact me at Teacher Wirz. It's TEACHER WIRZ as in zebra at hvacteaching.com or Teacher Wirz at cox.net, N-E-T. I respond as quickly as I can to all my emails, whether it's a question about what we offer or a question about service system that you're working on. Because the more people that contact me about problems they're having in the field helps me to learn better what is needed for my book updates and so forth. Very quickly on updates, I said that I have a bunch of material already ready for my 4th edition. I've also got some corrections to make. For instance, in the evacuation of a system, I show these very pretty pictures that my wife Irene made about hooking up the vacuum pump to a set of gauges. However, Appian, which makes probably some of the best evacuation recovery equipment out there, is saying, no, don't use your gauges. You should use a special evacuation manifold that doesn't have gauges on it. And they go into a process that I just touch on in there. So again, I'm always looking at the industry, looking at how to update my information in my book to become more relevant and helpful to people that are out there. So as far as Appian's concerned, what I have in my book is incorrect. I shouldn't have that gauge manifold hooked up to the vacuum pump in the system at the same time. So I'm learning all the time as well. And I'm just trying to spread the news as best as I can.
Spreading the gospel of refrigeration, spreading the good news.
Well, that's basically it.
That's it. And that's what I like about you don't typically see a textbook that changes as much as yours did from 2nd to 3rd edition. That's not typical. And when I say changes, 2nd edition is fantastic as well, but it's gotten so much better. And that's what makes you unique, and that's what makes your writing unique. I put you up there in the kind of the pinnacle of writing for this industry up there. I always bring up Dan Holohan because I love his writing on hydronics, and I would put you in that same kind of category, same echelon of writing, that it's really relatable. It's really good stuff. So for technicians who want to buy the book, because there's going to be a lot of people who want to buy the book after hearing this, do you have a preferred place that they go to buy that, or an easy place that they can get it?
Well, they can buy it on the Cengage website. Anybody who is an instructor actually can get a free copy, but they have the rep for Cengage in their area will contact them, make sure they are an instructor before they give them a free copy. Everybody else has got to pay the price tag, which is a lot higher than I would have liked it to have been, but I have no control over that. Amazon often has them a little bit cheaper. And let me see, they can also get it through ESCO. Once again, that's a teaching resource. ESCO is a branch of HVAC Excellence.
Yeah, and so Cengage, when you mention Cengage, that's, if you want to look that up, if you want to Google Cengage, that's just the letter C and then the word engage. So if you write C engage, that's Cengage, and that's where you can find it. And then I've actually bought a couple of my copies off of Amazon. And yeah, I mean, they're not cheap books, but they're worth it. It's got information that you're not going to find elsewhere.
Yeah, we have something else that we're working on, which is a diagnostic app. In my book, I came up with what I thought was a really good diagnostic chart. And I have taught it for years in the classroom, and I've used it in the lab sessions of the class. But I found that it did require some experience and understanding on the part of the technician as to whether this symptom was low or high or normal. But with the help of my wife, came up with an Excel spreadsheet type thing and put it on a laptop so that in the lab, the technician only had to put in temperatures and pressures, and then it came up with what the problem most likely was. Well, I have someone in San Diego that contacted me, and he had taken the course that I had taught an online course last fall through HVACR EduNet. And it's the first time I ever taught an online course. And it was commercial refrigeration, and we had tremendous response from technicians in Southern California who took the course. We had over 200 at a time. And one of them was actually a consulting engineer who said, I have made some apps for phones for technicians on superheat, subcooling, refrigerants, and so forth. How about if we work together on one from your chart? And this was started out last December, and we should go live with that in September. And it is called RefTech, and we're trying to figure out how to market it. But basically, it is an app where the technician will put down the high and low pressures, the suction line temperature, liquid line temperature, the ambient conditions, whether it's a walk-in or a reach-in, whether it's expansion valve or fixed metering device, and what refrigerant it is. And it will come up with a diagnosis, and not only a diagnosis, but the probable repair. There's 12 diagnoses, and one of those is normal. And the normal is extremely important because it can be used on startup of new equipment to make sure you have everything running properly. It can also be used in other cases where it wasn't the equipment's problem, it's just how it was used or it was sized improperly. So that's coming out next month, and that'll probably be on our website as well once we have that figured out.
Absolutely. So that website is hvacteaching.com, correct?
Yes, hvacteaching.com.
All right. So yeah, keep an eye out for that. If you want to check out his website, look for the book. And then Dick was kind enough to give us his email as well, which is teacher, Wirz, W-I-R-Z, at hvacteaching.com. So I really do appreciate it, Dick. It's been great. I encourage everybody to learn more from you, and for technicians to, if you've always been too afraid to work on refrigeration, start learning now. Start going to seminars and building up your knowledge so that when the time comes, you're ready to rise to the challenge.
Thank you very much. I appreciate you having me. And I can't leave without saying how much a pleasure it's been working with people like Jim Bergman. I talked about networks, and Andy Shane, who used to be with Sporlin, is now with, I believe, Hunua. Joe Jones, lead trainer of Heatcraft. Working with people like this, when I have a question, they are people that I can go to and get some honest answers, and I appreciate their input. And that is the networking that I'm talking about. And people that are listening to this, I hope they'll use me as a resource when they have a question. I'm around here all the time, work out of my house and ready to help.
Living the dream, living the dream. Yep. Thank you, Dick. I really appreciate it.
Thank you.
Okay, big thanks to Dick for coming on the podcast. Dick's a great guy, and I'm looking forward to having him on some future episodes, talking more refrigeration. I've gotten a lot of requests for that. A couple other little things I want to mention. As always, you can go to TrueTechTools.com. That's TrueTechTools.com. Buy anything there and get an 8% discount by using the offer code GETSchooled, all one word together, no caps, at checkout. You just look down in the kind of the middle left or bottom left of the screen. There's a place that asks for a coupon code when you're in the process of checking out or before you actually check out. Use the offer code GETSchooled there. Another product I've been talking a lot about is the pipe wiper. You can find that at ajaxmanufacturing.com. That's a-jaxmanufacturing.com. If you use the same offer code GETSchooled, you'll get 8% on that. And essentially what the pipe wiper does is it just helps flush out lines if you're not going to replace copper when you replace a unit without using solvents. There's a lot of reasons why solvents aren't the best. Not the least of which is that it's kind of nasty stuff. I mean, if you've ever gotten solvent in your eyes or on your hands, it's pretty bad stuff. And so not using that solvent helps reduce the risk of getting that stuff on you, and then also just kind of dumping it on the ground. You should be catching it and disposing of it properly, and I know a lot of guys aren't. So using the pipe wiper is a good way to do that, besides the fact that it just, in the long run, it's going to cost less, because a lot of these solvent products that you're using for flushing, they're actually pretty expensive. Whereas the pipe wiper, you can use the pig or mouse, whatever you want to call it, the wiper, you can use it again and again. And we've had really good luck with it. A lot of people ask what happens if it gets stuck. Our experience has been it doesn't. And if it ever did, in one case we had it get stuck, then you just blow it back out the other direction, and then you know you've got a good sized kink somewhere. So it actually tells you something about the system if it does ever get stuck. Anyway, that's the pipe wiper product. You can get that at a-jaxmanufacturing.com. Another thing that I want to mention is, Dick mentioned this, you can get a full refrigeration course from Dick, a full online course, by going to HVACR.edu.net. That's HVACR.edu.net. It's an investment, but I think it's a good investment if you want to get the full range of knowledge on commercial refrigeration if you're currently an HVAC technician. And another thing that I wanted to mention before I go is was recently there was I lost my leather bag that I use when I go on business trips. And good news, the detective, he found it within a minute. It was a briefcase. I think I'm gonna stop doing this. I think I lose the entire audience. Hey, I'll see you next time on HVAC School.